Hello to everybody. Today we will talk about the imperfect information problem, and this is the first one of the Philosophy of Computer Science series. This is an updated version, which I had presented this before, but now I have updated these slides and re-recorded. Well, we will talk about Philosophy of Computer Science series, so what we mean by that. Then I will briefly talk about software development processes, and I will then go into the problem of imperfect information and how you can possibly deal with this problem. So Philosophy of Computer Science series, I will present here a number of problems. In this series of talks, we will discuss a number of challenging problems in computer science. You may not directly apply these problems, or you may not directly connect to your own current business right now, but nevertheless, we think that being conscious about these problems can help us to widen our horizon and understand the fundamentals of science and engineering. So from that perspective, I believe knowing these problems are quite essential. Well, of course, we can refer to all kinds of terminology. So what is philosophy? What is philosophy of science? What is philosophy of computer science? Well, these definitions I took from Wikipedia, so I'm not very critical about these definitions. Basically, philosophy of science is a branch of philosophy concerned with the foundations, methods, and implications of science. And obviously, when we talk about the philosophy of computer science, we are referring to the context of computer science. Well, software engineering is the systematic application of engineering approaches to the development of software and also to the management of software. And we consider software engineering as a computer science discipline or computer engineering discipline. Well, perfect information is information that contains all the attributes and values with sufficient precision and certainty for the purpose for which it is used. When we look at this diagram, what we see here is that we see philosophy, software engineering. So there are these three circles overlap, and here we have imperfect information area, and then we are talking actually in the common area where all these three disciplines overlap with each other. So what is that imperfect information? I take this from Jos Noppen's PhD thesis from 2007. Dr. Noppen took his PhD from the University of Twente, and I was his main supervisor, and he described simply imperfect information is information that is not perfect. Well, what are then inherent problems? Inherent problems are the problems that cannot be solved perfectly. Nevertheless, of course, by doing research and developing all kinds of techniques, acceptable solutions may be found in practice. These problems are interestingly in the problem space, meaning that inherent problems are embedded in the nature of the problem context, and as such, they are not necessarily related to solution technologies. So no matter how the science and technology is advanced, these problems remain more or less. So they are really inherent and embedded in the nature of these problems. Competences for solving inherent problems, as we describe in this series, perfectly cannot exist in our physical world. The problems, however, addressed in these talks are in general in nature and can be experienced in different disciplines as well. However, to be specific and more concrete, I will give examples within the context of computer science and software engineering. And of course, we can possibly easily generate these, generalize these problems to the other disciplines as well. Well, in the series of philosophy of computer science talks, presentations which I will be given in the future are listed here. I will now talk about imperfect information, and other presentations will talk about the following, the remaining problems. So I have actually about 9 listed here. In fact, there are 10 problems because the second talk will combine two problems together. Well, what we try to discover is actually shown here. So here is the universe where we live. And this is the universe of inherent problems. And the imperfect information problem is in this universe. And there is a wall here which separates the imaginary universe of non-physical competences and our universe with the inherent problems. And the progress of science will help us to get closer to this wall, but we will never cross to the other side of the wall. Well, you may say, well, why we do all these things then if these problems are in principle unsolvable, at least perfectly unsolvable? Okay, but when we look at the medicine and all kind of research related to that, we also know that we will eventually die. However, we still do research in medicine to make our life better, to prolong our lives, to have a better living without suffering due to all kinds of diseases and such. So let's look at briefly at software development processes, because I will be referring to software development processes here. Well, I just explained what imperfect information is, and then we will classify or divide imperfect information in 2 categories. One we will call uncertain information, and that kind of information, well, information that is imperfect, but may eventually become certain at some point in the future. So we don't know now it is imperfect information, but it may become perfect, relatively perfect, at least in the future. For example, estimations about runtime behavior of software can become known after implementation. Imprecise information, however, their information that is imperfect and will remain imperfect to a certain degree. Especially when human beings are involved, we get such kind of information. For example, user satisfaction factor of software system may remain imperfect. So what is then software development processes? Well, our reference here is, of course, a very general reference to these processes. We won't be very much detailed about these processes, but we can consider software development processes as a refinement process. So typically you start with customers' requirements, and then you process these customer requirements into the following phases. For example, you analyze the requirements, you conceptualize the problems to be solved, searching for possible solutions, expressing the chosen solution in some design notation, design pattern, whatever, and finally mapping the design manually or automatically to programs expressed in some programming language. Maintenance of the delivered software products is also an essential part. Actually, we know that maintenance costs, most of the time it costs more than development. And there are all kinds of suggestions and publications about the phases of software development life cycle. It can be in strict order, or it can be iterative. You may use, for example, agile methods and so forth. Well, software development is in the world of imperfect information. So software development processes, they are influenced a lot by all kind of imperfect information. And the quality of software system, of course, inevitably depend on the quality of information sources. And whatever you do, information sources contain, to, of course, varying degree, imperfect information. For example, due to ambiguous or incomplete and evolving requirement specifications. Requirement specifications continuously evolve, and you don't really know what people may expect from the systems you develop also in the future. Even before you complete the software product, requirements may change. And also tolerance in estimations about the project data, software quality, and so forth. So software development processes are influenced a lot by the imperfect information. It is inevitable. Well, also when you look to typical software development processes, the world markets, software development customers, companies, their customers, the adopted technologies, the context that they operate, they are all in continuous change. We cannot close a typical software product into an area and say, hey, nothing will change after the delivery. That's not realistic. Closed world assumptions, what we call them, are not realistic in general. It's largely connected and open world. And information collected in this context to a varying degree is not perfect. So imperfection is always there. Well, what is then the imperfect information problem? So the question may be, well, we can make imperfect information perfect by iteration. So when you develop software, you can iterate the process till the information you have is perfect or becomes perfect. Well, that means maybe sometimes small iterations in small scale, or even sometimes the whole project may be iterated. So what we say, however, is that iteration can never remove imperfection. There will be always imperfection, even if you iterate through the software development life cycle. There will be always some imperfect information there. So we defined actually 4 requirements in order to remove imperfection after iteration. And what we claim is that these 4 requirements cannot be fulfilled in general, at least not perfectly. So if you want to remove imperfection through iteration, for example, you are trying to improve this part of software, this is a typical software diagram. It's actually called a diagram. All these small rectangles are actually, these are all software modules, and these are whole relations about among software modules. And let's say we take this part of software and we want to iterate through this part and make this perfect. We say that in order to remove imperfection, for example, in this part of software, you have to fulfill the all isolation requirement. That means all relevant concerns must be independent from each other so that concerns that are influenced by imperfect information can be isolated and made perfect eventually. So, for example, in this part, the second requirement to remove the imperfect information problem is always requirement, what we call it. That means all requirements must be frozen so that new requirements will have no influence. So here we assume closed world assumption that no new requirements will appear. Therefore, when we iterate, we can eventually remove imperfect information. Other requirement is all at once requirement, which means that, for example, here you may iterate in different parts of software. You divide software in different ways. You may, of course, iterate due to changes in requirements. You may iterate because some parts of software are influenced by let's say, the imperfect information, or you may iterate through the whole project. All at once requirements means that all imperfections must be resolved at the same time. Otherwise, there will be always some influence of imperfect information. Because if you, for example, try to improve some part of the software, because you cannot perfectly isolate, assume that you make it, try to make perfect, but the other parts will influence the part that you are working on. So that means you have to remove imperfection at all parts at the same time. In this requirement, all infinite requirement, we assume that all the required resources for iterations must be infinitely available. Otherwise, iterations cannot be applied until the imperfections are resolved. So which means that you keep on iterating, you have all the time till infinity, and you remove all imperfections because you go to infinity. Of course, we know that this is not realistic. So when we look at the picture where we depict the universe of inherent problems and we assumed an imaginary universe of non-physical competences, we have these 4 competences on the other side of the wall: all isolation competence, all infinite competence, all always competence, and all at once competence. And all these competences cannot be fulfilled in our side of the wall. And this is the universe of the imperfect information problem. So how do we deal with this problem? We may not solve this problem perfectly, but we can do some research and we do some development activities and we try to resolve these problems to a certain degree, but of course not perfectly. Well, what you can do is you try to improve the quality of information. So you first of all gather information from multiple sources, collect also meta information on, for example, maturity, age, and trust for each information source and track their propagation through development decisions. Try to track actually. give priority to reliable resources, filter noise and other unwanted effects of information. You can use, of course, domain-specific models and ontologies to minimize imperfection. For example, by classifying imperfection further and try to, by this way, minimize its effects. A very important step is to defer abrupt and too early decisions as much as possible, because at the early phases, you are more subject to imperfection. So you try to gather information and try to improve your information along the development process. To minimize imperfection, iterate if applicable. Of course, we said iteration cannot remove, but iteration is, of course, a good way of reducing imperfection. Use feedback loops, data analytics, and machine learning techniques to improve information as much as possible. But of course, all these techniques are also limited to some degree. Well, another way of dealing with imperfection is to represent imperfection instead of ignoring it. Software engineering as a discipline has been working with imperfection. For example, when we deal with requirements, we always say, said also in the literature in the past, that requirements can never be made perfect. In essence, it's becoming clear that this extends to any information source and decision process. It also highlights that this field aligns with human-in-the-loop AI systems, as developers can remove imperfection when new knowledge emerges. Secondly, use again domain-specific models and ontologies. Use pattern recognition, data analytics, and machine learning techniques to model imperfect information. You can use, of course, also appropriate techniques such as fuzzy and fuzzy probabilistic techniques to model and represent imperfect information. Use these models to minimize the effect of imperfection, for example, by adopting feedback loops and optimization techniques. Explore what if and impact scenarios to assess risk and impact to inform decision making. Automate ingestion and reasoning with imperfect information, as its complexity can increase rapidly when system size increases. So imperfect information and its effect, of course, is also related to the size of the project and the software you develop. In all these publications, Jos Noppen was part of this research work because of his PhD thesis, and also Pim van den Broek was also part of the team. Now I would like to present our related research work. The term imperfect information has been adopted by the researchers in the area of fuzzy sets, expert systems, and databases. So these terminologies existed. And if you would like to refer to the paper where the definition of imperfect information problem was published, it can be found in the reference, which these references I will present in the follow-up slide. We have studied this problem for different phases of software development, such as requirement specification, architecture design, software design, application, framework design, determining and optimizing quality attributes of software systems. So we have carried out substantial research in this area. In these approaches, to address the imperfect information problem, generally a model of a design process is defined. So you say, okay, this is the model of my software design, and you adopt fuzzy and fuzzy probabilistic techniques to represent imperfection instead of ignoring its existence. Imperfect information sources are modeled also in this way. And by using various optimization techniques, the most suitable alternatives are searched and selected. So the key issue here is to represent information, imperfect information, instead of ignoring it, gather more information, and eventually make your decision, but don't decide too early and in an abrupt way. By this way, negative influences of the imperfect information problem is aimed to be reduced. So here are some publications. Some of them, most of them are our publications. The first one, and after starting from the fifth one, here we refer to our publications in this context. And Jos Noppen has continued this work after his PhD, and he has supervised another PhD student in this area. And here there are some references to his work. And actually, very interestingly, his work can be applied, for example, to detect bugs in software based on historical data. So these are the continuations of his work. And I also received a list of publications. These are more recent publications by Professor Antonia Valesilo, and you can refer them if you want, if you need these papers. I think he also gave a very interesting talk in the conference what we have organized, and you can refer to that or reach to that talk also by referring to the first link here. Thank you very much for your attention.